So what we have here is a balance board controlled far seat tank.
For rehabilitation purposes, a lot of physical therapy offices will have balance board type of exercises for people to do. And so our idea was to make it a more enjoyable experience because rehabilitation can take a long time. So the basic premise is to use balance control and like basic motor skills to control a tank, and the idea is that you could design like a maze for someone and they'd have to balance in such a way that the car would maneuver through it.
So the way it works is it has an accelerometer on the balance board that uses an RF transmitter to communicate with an RF receiver over here, and it just powers these two DC motors. You start by turning on this power switch here. It says welcome, place board flat. Then it says calibrating, which is calibrating the accelerometer to get a 0. If I tilt this forwards, the tank will drive forwards, backwards. Then it can also turn. It's harder than it looks.
It really is. We didn't actually consider the how difficult the balancing would be. All right.
It's all controlled by two 16F88 microcontrollers. So they're just sending serial information through the RF transmitter.
The accelerometer, it's triple axis. We only ended up using 2, just in the X and the Y. When the board starts up, it calibrates, so it finds that base value and then sets upper and lower thresholds. Depending on how you tilt, the X or the Y axes will go above or below those threshold values. And if it does, the board sets it into drive, back, left, or right mode. And then it sends that mode value to the tank, which the pick on this end receives it, and then drives the motors in that direction using a dual H bridge, which lets both of our DC motors run in both directions. And that's what allows us to get that rotation motion out of just 2 motors.
Inside the balance board itself, you can see that there's a breadboard and the accelerometer here, and the RF transmitter here, and the little speaker here. And it has 2 battery packs. One is to power the accelerometer, and the other is to power everything else.
And for our tank, it's made out of Legos, as you can see. It has 2 main assembly sections. The battery holder here, and that has wires going down to the lower housing, the motor, and the breadboard housing. You can see our 2 Lego motors that are geared down to the treads. And you can see in here our H bridge. Our RF controller or receiver is underneath this green piece here, and our pick is right there.